Right, so we looked at alkanes and alkenes before, but just for the sake of the video then, an alkane is the simplest of the organic compounds. It's simply a bunch of carbons with covered in hydrogens, okay? So we say it's saturated because no more hydrogens can fit onto it, okay? So that one would be ethane. The ane part is what tells me it's an alkane, and the eth part is just tells me how many carbons. An alkene would always end in ene, and again, the beginning part tells me how many carbons, but this time it's got a double bond. So we'll do propene this time. So that's, once I've drawn the rest of it, we'll see that that's propene. But so we've got that carbon now has the 4 bonds, so we fill it with the hydrogen. This carbon's already got 3 bonds, so it just needs 1 more. There we go. And this carbon on the end has got 2 bonds already, so we'll give it 2 more. That's propene. Now, alcohols. Alcohols are just like an alkane, only one of the carbons has got an O and then an H on it. And it ends in anol, okay, ethanol, propanol, okay, those are alcohols. Carboxylic acids, the one of the C's has got a double bond to an O and then an OH group. So, and it ends in anoic acid. So this is 3 carbons, prop anoic acid, eth anoic acid, methanoic acid. So yeah, now what we want to do next then is, before I just I'll look at esters in a moment, is to talk briefly about what a functional group is. Remember, the functional group is the thing that defines what kind of homogeneous series it is, okay? The name of the homogeneous series is it alkanes, alkenes, alcohols, carboxylic acids, and esters. So that's the functional group because that's what makes it an alkene. That's the functional group because that's what makes it an alcohol. That's the functional group because that's what makes it a carboxylic acid. So let's have a look at esters then. So an ester is what is made when you react when you react to carboxylic acid with an alcohol. So let's look at an example of this. I'll take ethanol and I'll take propanoic acid. And I'll get rid of these highlighted functional groups and maybe make that a little bit thicker. So they're going to react together. Now, what happens is they join together, but something breaks off. So this is the bit that I need to often remind myself of. It's the carboxylic acid where the OH comes off. Okay, I'm going to use a different highlighter actually because the green was for functional groups, wasn't it? So this bit breaks off. Actually, no, what I'm going to do, I'm just going to colour in the O and the H. Like that. And this bit breaks off, yeah. So, and then it joins together. So it would help actually if I were to maybe flip this around. Oh, but now it's got the C's backward. Oh, okay, fine. So you can imagine, well, maybe I'll just do it for the animation. Just do it for the video. So if I take this, no, I'll tell you what, I'm just going to pause the video and redraw my carboxylic acid. But I suppose this is how you would normally draw your carboxylic acid. But I'm going to draw it back to front because I want the O and the OH to be on the left side, at the same side as this hydrogen. Okay, so I'll just pause the video and do that. Right. Okay. So they're now on the same side. So as I said, these two bits are going to break off, and the rest of it's going to join together. So if I take this down here, take this down here, and I'll just ungroup that. I'm going to do, let's get an arrow here. So this is up here. These two are the reactants then. They were there before the reaction. And we'll make, and these two, what's going to occur down here, these are going to be the products. So as I said, the hydrogen breaks off and the OH breaks off. Oh, I didn't want to, I wanted to move it off like that. And then they form a water molecule. So there's my OH group. I want to make that all red. So that's H2O, right? We've seen that before. And then these two join together. Like that. Oh wait, no, they don't join together like that. Okay, hang on, let me just pause the video again. Okay, yeah. So this is when I'm gonna have to turn it around again. Okay. Oh no, I just realised there's something wrong. When I did it up here, this oxygen needed to be over there as well. I flipped it around, but I didn't flip it completely around. Okay, because the functional group's been split up, hasn't it? Okay, let me just sort that out now. So I should have done like that. Yeah, that I thought something didn't seem right. And that goes there. Okay, all right. So let's just get that bit there. So we've got, yeah. So we've taken off the OH and the H, and it's formed this water molecule, and then it joins together. But actually, what happens is this oxygen moves around, and the oh no, I've still not got it right. This is not a good video. So yeah, sorry. Let me just change this. Right. Okay. Let me move it around again. We'll move this over to here. Like that. It's still a carboxylic acid. Okay. And we'll move the oxygen over there. And then we just need to draw a bond to connect those two. I'm going to just erase this bit. We'll do this bit again. Because it's not that hydrogen that breaks off. So I'm going to move that up there. No, in fact, I'll just delete it. And I'm going to move this down here. Move it all to the left a little bit. And that joins with another hydrogen there. And let's just erase that and draw that. Okay, it's this hydrogen that breaks off. Okay, there we go. Oh, and so actually, yeah, this one could have stayed up there. Oh, okay, this one could have stayed up there. Okay, it doesn't matter if this one's there or there anyway. So we've broken off the that hydrogen and this OH to form that water molecule. Now we take the rest of the rest of each molecule like that. And we stick them together. And the thing to notice is that, whoops, we have this oxygen in the middle of the chain, and that's kind of what makes the esters look strange. We have this chain, but it's not a chain of carbons. It's got the oxygen in the middle. And so now let's use some color again. So this is the rest of the alcohol then. We'll make blue, and we'll make the carboxylic acid, we'll make that, let's say, green. Then we can highlight that on here. I just taught esters as well. I shouldn't have got this wrong. So there's my ester molecule, and I've just highlighted it so you can see which part came from what. So esters are probably the hardest of the compounds, but you don't need to know much about it. You need to understand what's happened there, but you probably won't need to recreate what I've just done. This is naming esters is weird, and I don't think you'll need to know how to name them, but it's good to understand it anyway. This bit on here, we call that's the ethyl group, or it could be a methyl group, or so the eth, because there's two of them, right? And then the oxygen splits the naming, and then the next part of it is where we name the rest of it. So we've got 1, 2, 3 carbons this time. So it's prop and anoate. Okay, so the anoate is the anoate is what means it's an ester. So I can maybe make this bit blue and then make this bit green. And then you've got this water molecule as well. Okay, right, hopefully that, let me just pause the video.